Welcome students to online classes of mathematics for class 9th. In this video we are going to study chapter number 9, which is areas of parallelogram and triangles of NCERT textbook. And this one is the session number 4 for this particular chapter. Here we will be looking at the question number 4 to question number 10 of exercise 9.3. That's why I have written it as part 2nd. Okay, remaining question will be covered in the part 3 of this exercise. Okay, myself Deepak Gautam, TGT Mathematics, Kendriya Vidyalaya Sangatam. So let's start with the today's class. Since we have already done the first 3 questions in the previous session, now we are going to start with the question number 4. So the question number 4 is, in figure 9.24, ABC and the ABD are the two triangles on the same base AB. So here we have two triangles. One is this triangle ABC and second one is the triangle ABD, which are on the same base AB. Okay, if the line segment CD is bisected by AB, so we have this line segment CD which is bisected by AB. That means that these two portions are equal. Okay, so here we have two triangle ABC and ABD, and which are on the same base AB, and the line segment CD is bisecting the side is bisected by the AB at O, and we have to show that the area of the triangle ABC and ABD equal. So we have to show the area of triangle ABC, this one, and ABD is equal. Okay, so we are going to use the statement of the example number 3. Okay, so let's first write the given part. This is the answer number 4. First we will write the given. Given here is two triangle ABC and ABD. Two triangles ABC and ABD which are on the same base here is AB. Okay, these two triangles are on the same base AB, and AB bisects CD at O. Okay, we have this side CD which is bisected by AB at point O. Okay, we have to prove here is we have to prove that the area of the two triangles, that is ABC and ABD, are equal. That is, area of triangle ABC is equals to area of triangle ABD. Okay, so let's start its proof. So in its proof, what we have is, since this CD is bisected by AB, that means that these two portions are equal. That means this AO will act as the median for the triangle ACD. Also this OB will act as the median for the triangle BCD. Okay, so these two will act as the median for these two triangles. Okay, so we are going to use this in triangle ACD. Okay, we'll write in triangle ACD. We have this OC and OD are equal. In triangle ACD, we have OC equals to OD. Hence, OA is the median for triangle ACD. Hence, OA is the median for triangle ACD. Therefore the area of the two triangles, which is these two triangles, will be equal. Area of these two triangles will be equal. That is, the area of triangle AOC will be equals to area of triangle AOD. That is, area of triangle AOC will be equals to the area of triangle AOD. This is by the statement of the example or the question of example number 3, which says a median of a triangle divides into two triangles of equal area. Okay, so we got, since OA is the median for the triangle ACD, so the area of these two triangles will be equal. Okay, similarly in triangle, the next triangle is triangle BCD. In triangle BCD, we have in triangle BCD we have that the OC equals to OD, hence OB is the median for triangle BCD. Therefore the area of triangle BOC will be equals to area of triangle BOD. Again, the reason for this one is the example number 3. Okay, let's name this equation as equation 1 and this one as equation 2. Now on adding the two equation, we'll add the right hand side term to the right hand side and left hand side term to the right hand side. Okay, so right on adding the equation 1 and equation 2, we get what we get is we'll add the left hand side term to the left hand side, that is area of triangle AOC plus area of triangle BOC equals to area of triangle AOD plus area of triangle BOD. Okay, now this AOC and BOC will give us the area of triangle ABC, and the sum of the area of triangle AOD and BOD will give us the triangle area of triangle ABD. Okay, and this is what we are asked to prove, that we have to prove that the area of triangle ABC is equals to area of triangle ABD. Okay, so we have applied the statement of example number 3 in these two triangle, and taking this OA and OB as median, we got the area of these two respective triangles equal, and after adding the two we'll get the required result. Okay, I hope you understood. Now moving to the next question, which is question number 5. It says D, E and F are respectively the midpoints of the side BC, CA and AB of triangle ABC. Okay, so we have 3 points which are D, E and F are respectively the midpoint of BC, CA and AB of a triangle ABC. Okay, we have to show here for 3 things. First is that BDF is a parallelogram, then area of DEF is 1/4 the area of ABC, and the area of BDEF is half the area of ABC. Okay, let's first draw its figure. So this is the figure for this question. So let's write its answer number 5. First we'll write the given part. Given here is a triangle ABC, in which D, E and F are the midpoints of the sides BC, CA and AB of triangle ABC. Okay, now we have to prove here 3 things. To prove is first we have to prove that this BDEF is a parallelogram. Then we have to prove that the area of DEF is equals to 1/4 the area of triangle ABC. And now lastly we have to prove that the area of BDEF is equals to 1/2 area of triangle ABC. Okay, these are the 3 things which we have to prove. So let's start its proof one by one. Proof of part 1. Here we have to prove that the BDEF is a parallelogram. Okay, that BDEF is a parallelogram. So we are going to use the midpoint theorem here. Since this E and F are the midpoint of the side AB and AC, when you join them, that has to be parallel to the third side. That's what the midpoint theorem says. The midpoint theorem says if the midpoint of the two sides is the line segment drawn to join the midpoint of two sides will be parallel to the third side. Okay, that's what this midpoint theorem says. Now we are going to use that statement here, so which is in triangle ABC, EF is parallel to BC. This is by midpoint theorem. Okay, which says if the line segment joining the midpoint of two sides will be parallel to the third side. Okay, so therefore we can write this as EF is parallel to, instead of writing this complete BC, we can write this as BD. Okay, let's name it equation number 1, and we can write also this second side. Now you can see this D and E are the midpoint of BC and AC, therefore this has to be parallel to the third side AB. Okay, again we'll write also DE will be parallel to AB. This is by again midpoint theorem. The theorem says the line segment joining the midpoint of the two sides, you can see this is the line segment joining the midpoint of these two sides, and this has to be parallel to the third side. Okay, so this DE has to be parallel to AB, or we can write this as therefore DE will also be parallel to the, instead of writing this complete side AB, will write FB, and let's name it equation number 2. Okay, now what we got here is in this parallelogram, or you can say in this quadrilateral, the each pair of opposite side is parallel. That means this will be a parallelogram. Okay, so we can say that from equation 1 and 2, from equation 1 and equation 2, we get what we get is that BDEF is a parallelogram. Okay, we get BDEF is a parallelogram because we have proved that it's each pair of opposite side is parallel. Okay, so that EF is parallel to BD and D is parallel to FB. Since the each pair of opposite side is parallel, so this BDEF will be a parallelogram. Okay, now let's come to the part second. Proof of part second. Here we have to prove that the area of DEF will be equals to the area of half 1/4 the area of ABC. Okay, so what we're going to do here is we have already proved that BDEF is a parallelogram. Okay, in similar way you can prove that this is also a parallelogram, and then we can also prove that this is also a parallelogram. Okay, so this triangle is made up of 3 parallelograms. Okay, so we'll write since BDEF is a parallelogram, similarly we can prove that FDCE and AFDE are parallelograms. No need to show this process again, we just directly can write since this BDF is a parallelogram, in similar way we can also prove that FDCE is a parallelogram and AFD is a parallelogram. Okay, so what we got here is the all these 3 figures are the parallelogram. Okay, and we know that in a parallelogram of a the diagonal of a parallelogram divided into 2 triangles of equal area. Okay, so using that statement we can write that Therefore, since this PDF is a parallelogram, so it's the respective two triangle area of those two triangle will be equal. So we can write, therefore area of FBD will be equals to area of DEF. Okay, since reason for this one is because this DF is a diagonal of parallelogram BDEF. Okay, reason for this one is since FD is a diagonal of parallelogram BDEF. Okay, that's why we can write that area of these two triangle is equal. Let's name it equation number 1. Okay, we can write similarly area of the other two triangle, that is this DEC and DEF will also be equal. Okay, similarly area of DEC will be equals to area of DEF. Okay, reason for this one is again same, because now this side DE is the diagonal. Okay, or you can write because ED is a diagonal of parallelogram BDEF, sorry, FDCE. Okay, that's why the area of this triangle will be equal. Let's name it equation number 2. Okay, and in similar way we can write for the third parallelogram that the area of the triangle, these two, now this one and these two triangle will also be equal. That the AFE, the area of triangle AFE will be equals to area of triangle DEF. Okay, reason for this one is now this FE is a diagonal. FE is a diagonal of parallelogram AFDE. Let's name it equation number 3. Okay, so what we got is in 3 equation the area of triangle FBD is equals to DEF, area of DEC equals to DEF, area of AF is equals to DEF. That means the area of all these 3 triangles equals to DF, which means the area of all 4 triangle is equal. So right from equation 1, 2 and 3 we conclude, or we get from equation 1, 2 and 3 we get, since the area of all 3 is equals to a same triangle which is DEF, that means the area of all 4 triangle will be equal. Okay, so we can write area of first triangle is FBD is equals to area of triangle DEC will be equals to area of triangle AFE will be equals to the area of triangle DEF. Okay, so the area of all 3 triangles is equals to DF, that means the area of all 4 triangle is equal. Let's name it equation number 4. Now we can write that therefore area of triangle ABC will be equals to the sum of the area of triangle FBD plus area of triangle DEC plus area of triangle AFE plus area of triangle DEF. Since the area of all 4 triangle is equal, we can write this as 4 times the area of triangle DEF. Okay, that is the area of ABC will be equals to the 4 times the area of DEF, or we can write this as keeping this area of DEF here, area of DEF When you shift this 4 to the other side, it will become 1 by 4 area of triangle ABC. Okay, and this is what we are asked to prove here. Okay, come to the part 3 of this question. Here we have to prove that the area of BDF is equals to half the area of ABC. Okay, we can write 4 parallelogram is that we are taking is BDEF. We can write the area of parallelogram BDEF will be equals to the sum of the area of triangle BDF, this sum of the area of angle, this first one FBD plus area of triangle DEF. Okay, or since the area of these two is equal, we can write this as twice the area of DEF. Okay, and we have proved that in the part second that the area of BDF is 1/4 the area of ABC. So we can write this 2, and at the place of this area of DEF we can write 1 by 4 area of triangle ABC. Okay, this 2 will be cancelled out by the 4, we'll get it as 1 by 2 area of triangle ABC. And this is what we are asked to prove, whether the area of parallelogram BDEF is equals to 1 by 2 the area of triangle ABC. Okay, so that's the solution of all 3 part of question number 5. Okay, I hope you understood this. Now moving to the next question. Question number 6 is, in figure 9.25, diagonal AC and BD of quadrilateral ABCD intersect at O such that OB is equals to OD. So we have this quadrilateral ABCD. So remember, it's not given as the parallelogram. Okay, we are just mentioned here that this is a quadrilateral. Okay, so we have the quadrilateral ABCD in which the diagonal AC and BD intersect at O such that OB and OD are equal. So we are given this OD and OB are equal. Okay, and if AB goes to CD and these two diagonal AB and CD are also equal, then we have to prove 3 things again here, that the area of triangle DOC is equals to area of triangle AOB, and area of triangle DBC is equals to area of triangle ACB, and the DA is parallel to CB, hence ABCD is a parallelogram. Okay, this is what we have to prove. So ABCD is not given as parallelogram, we have to prove that ABCD is a parallelogram. Okay, so let's start first by writing the given part. This is answer number 6. Given here is, like I said, you always have to write the name of the figure. So we are given a quadrilateral here. So given is a quadrilateral ABCD in which AC and BD are its two diagonal. Which intersects at O. Which intersects at O such that OB is equals to OD and AC is equals to AB is equals to CD. So we are given the two side AB and CD as equal. Okay, the opposite side of this parallelogram are given equal. This is CD. So what we have to prove here is, we have to prove again 3 things to prove. First, we have to prove that the area of triangle DOC is equals to area of triangle AOB. Second, we have to prove that the area of triangle DCB is equals to area of triangle ACB, and area of triangle third is DA is parallel to CB, or you have to prove that ABCD is a parallelogram. Okay, let's start this proof. We'll start with the construction. What we're going to do here is we will draw two parallel perpendiculars from point B to M and from D to side AC at point N. Okay, so what we're going to do is we'll draw two perpendiculars. First, let's write the construction. First is draw. What we have to do is we'll draw two perpendicular. Okay, draw DN perpendicular on AC and BM also perpendicular on AC. That will be here. First we'll draw this BM like here, and we have to draw DN. So let's name this point as M here and N here. Okay, so we have named them DM and DN, BM and DN. Okay, so let's start this proof. Proof of part 1. Here we have to prove that the area of DOC and BOD are equal. So we are going to start with the two triangle DOC and AOB. Okay, that means these two triangles. Now we are going to start with the two triangle, these two triangles. Okay, in triangle DON and triangle BOM. Okay, so we'll start in triangle DON and triangle BOM. What we have is we have the angle DNO is equals to angle BMO. Each is of 90 degree. Each of 90 degree. Okay, and we have the angle DON is equals to angle BOM, because they are vertically opposite angles. Okay, and we are given that OB is equals to OD is equals to OB. So what we got is we got an angle and a side. Okay, we got angle side. So by AA as congruence rule, these two triangles will be congruent. Okay, so we can write therefore triangle DON will be congruent to triangle BOM. This is by angle side congruence rule. Okay, so we can write that these two triangles are congruent by angle side congruence rule. Okay, then what we are going to work in the other two triangle, in these two triangle, in triangle DCN and in triangle BAM. Okay, we'll write now in triangles DCN and triangle BAM. Okay, DCN and BAM, angle D and C will be equals to angle BMA. Each will be again of 90 degree. Each of 90 degree. Okay, now next is that we are given that DC is equals to AB. This is given to us in the question itself. Okay, and we have this DN is equals to BM. Okay, this DN and BM will be equal because we have proved that these two triangles are congruent and their corresponding side will be equal. Okay, so we'll write since the triangle DON is congruent to triangle BOM, that's why these two sides will be equal by simplicity. Okay, so what we got here is we got a right angle okay, and hypotenuse and a side. Therefore by RHS criteria these two triangles will be congruent. Okay, so right, therefore triangle DCN is congruent to triangle BAM, and this is by RHS congruence rule. Okay, now let's name this one as equation number 1 and this one as equation number 2. After adding the two equations, what we get is, on adding equation 1 and 2, we get, what we get is, since these two triangles are congruent, and their areas will also be equal. Similarly, since these two triangles are congruent, their areas will also be equal. So we'll write area of triangle DON plus area of triangle DCN will be equals to area of triangle BOM plus area of triangle BAM. Okay, after adding these two, we'll get the triangle DOC, that is area of triangle DOC, and on this side, after adding the two, you will get the area of triangle AOB. And this is what we are asked to prove, that the proof area of triangle DOC is equals to area of triangle AOB. Okay, so we have proved the first part of the question number 6. Now let's move to the next part, proof second. Okay, since in the first part 1 we have already proved that the area of triangle DOC and AOB are equal, so we are going to use this one again. Okay, so we'll write, we have that area of triangle DOC is equals to area of triangle AOB. This is proved above. Okay, now what we are going to do is, we are going to add the area of this region, that is area of BOC, in both the triangle. Okay, so write, on adding area of triangle BOC on both side in above equation, we get, what we get is, now we are going to add the area of BOC in both sides. It is area of triangle DOC plus area of triangle BOC equals to area of triangle AOB plus area of triangle again BOC. So what we did here is, we have added the area of BOC on both sides in this equation. Okay, so as a result of this, when you add the DOC and the BOC, what we get is, we'll get the area of triangle. Alright, therefore after adding the two, we'll get it as equals to area of triangle DBC, area of triangle DCB, and after adding AOB and BOC, we'll get the area of triangle AOB, sorry, ACB. Okay, and this is what we were asked to prove in the part second of the question number 6. Okay, now let's move to the part 3 of question number 6, that is proof 3. In this one, we have to prove that DA is parallel to CB, and hence the ABCD is a parallelogram. Okay, now since we have proved that the area of DBC and ACB are equal and they are on the same base BC, therefore they must be lying between the same parallel. Okay, since area of triangle DCB is equals to area of triangle ACB and they are lying on the same base here is BC, therefore by theorem 9.3 they must be lying between the same parallel. Okay, therefore DA must be parallel to CB. Hence ABCD is a parallelogram. Okay, since we have its both pair of opposite side parallel, so this ABCD will be a parallelogram. Okay, so that's the answer of question number 6 of exercise 9.3. Now let's move to the next question, which is question number 7. The question is, D and E are points on the side AB and AC respectively of triangle ABC. So let's draw its figure first. This is the figure for this question. As it say, we have the D and E are the point on the side AB and AC, okay, such that the area of this triangle is equals to the area of this triangle. Okay, area of these two triangles are given as equal, and we have to prove that this DE is equals to BC. Okay, so we'll start by writing the given. Let's write the answer number 7. Given here is a triangle ABC in which D and E are the points on sides AB and AC respectively, such that the area of triangle DBC is given equals to area of triangle EBC. Okay, so these are the information given to us in this question. What we have to prove here is we have to prove that this DE is parallel to BC. Okay, this is what we have to prove. Now let's start its proof. This is a very simple question, as it is given that the area of the triangle DBC, which is here, this DBC, this one, and the area of triangle EBC are given equal, and they are sharing a common base. Okay, so we'll write, since the area of triangle DBC is equals to the area of triangle EBC and they are lying on the same base BC. Okay, therefore the side D, they must be lying between the same parallel, that is DE must be parallel to BC. This is by theorem 9.3. You have to write the statement of the theorem 9.3, which says, if the area of two triangle is equal and they are lying on the same base, then they must be lying between the same parallel. Okay, if the area of two triangle is equal and they are on the same base, then they must be lying between the same parallel. So since we already have the area of two triangle equal and they are lying on the same base BC, then they must be lying also between the same parallel. Okay, hence the DE must be parallel to BC. Okay, so that's the answer of question number 7. Now moving to the next question. This is question number 8. This question is, XY is a line parallel to BC of a triangle ABC. So we have a line triangle ABC in which XY is a line parallel to BC. Let's draw a line segment XY here. Okay, further is saying the BE is parallel to AC. So we have another line BE, which is parallel to AC. Okay, so since AC is here, BE will be somewhere here. Okay, and CF is parallel to AB. So we have AB here, so CF will be on this side. This will be CF, and they are meeting XY at point E and F. So when you extend this, you will get a figure like this. Okay, because this XY when extended are meeting at E and F respectively, and we have to show that the area of triangle AB is equals to area of triangle ACF. That is area of triangle ABE, this one is equals to the area of triangle ACF, ACNF. Okay, let's draw its figure first. So that's the figure. We have the triangle ABC in which X and Y are produced to meet the point E and F, and this EB is parallel to AB, and this CF is parallel to, sorry, EB is parallel to AC and CF is parallel to AB. Okay, so let's start with answer. First we'll write the given part. This is answer number 8. Given here is, we are given that a triangle ABC, a triangle ABC in which XY is a line parallel to BC. XY is a line parallel to BC. Okay, and BE is parallel to AC. Also CF is parallel to AB. Okay, and we have to prove here that the area of triangle ABE is equals to area of triangle ACF. Okay, let's locate the two triangle. ABE is this one and ACF is this one. Okay, so we have to prove that the area of these two triangle equal. So what we are going to do here is, first we will take the two parallelogram, which are the parallelogram BCYE and the parallelogram BCFX. These two parallelogram are on the same base BC. Since this XY is parallel to BC, that means they are lying in the between the same parallel. Okay, so therefore the area of these two parallelogram will be equal. So let's start this proof. Okay, so first we are going to prove that the area of the two parallelogram is equal. So we'll write, since parallelograms, first parallelogram is BCYE and parallelogram BCFX are on the same base. Same base here is BC and lying between the same parallel, parallel lines here are that we have this EF is parallel to BC. Okay, since this XY is given parallel to BC, so this entire line, complete line EF will be parallel to BC. Therefore the area of parallelogram BCYE will be equals to the area of parallelogram BCFX. Okay, so the area of the two parallelogram will be equal. Let's name it equation number 1, and this is by theorem (9.1). Okay, we have named this equation 1, and this is by using theorem 9.1, which says if two parallelogram are on the same base and between the same pair, then the area of the two parallelogram have to be equal. Okay, now moving ahead, further we have, what we have here is that, now look at the first triangle, which is triangle ABE, this one ABE, and the parallelogram BCYE. Okay, this triangle ABE and the parallelogram BCYE are on the same base EB and between the same parallel EB and AC. Okay, so we'll use the statement of the example number 3, which says if a triangle and a parallelogram are on the same base, then the area of triangle will be half the area of that parallelogram. Okay, so we'll write, we have triangle here is ABE and parallelogram, the parallelogram B is BCYE are on the same base. same base here is now EB. Okay, this one is the same base, and between the same parallel lines here are that AC is parallel to EB, which is given in the question that this BE and AC are parallel. Okay, and they are lying between PE parallel to AC. Therefore area of triangle ABE will be equals to half the area of triangle, parallelogram BCYE. Okay, let's name it equation number 2, and this is by the statement of the example number 2, which says if a triangle and a parallelogram are on the same base and between the same parallel, then the area of triangle will be equals to half the area of parallelogram. Okay, and similarly for the second triangle, this AFC, or you can say ACF, and the parallelogram BCFX, again they are on the same base CF, and between the same parallel CF parallel to AB. Okay, so we'll write the same thing. Similarly, the given second triangle is ACF, and parallelogram here is now BCFX are on the same base here now is CF, and between the same parallel lines here are that the CF is parallel to AB. Okay, which is given in the question as CF is parallel to AB. Again, therefore what will get is that the area of triangle ACF will be equals to half the area of parallelogram BCFX. Let's name it equation number 3, and this is again by the statement of example number 2, which says if a triangle on a parallelogram are on the same base and between the same parallel, then the area of triangle will be half the area of parallelogram. Okay, what we got here in these three equations is that first we got the area of this parallelogram BCYE and BCFX are equal, and then we got that the area, half the area of this BCYE is equals to the area of triangle ABE, and similarly half the area of BCFX is equals to the area of ACF. Okay, so from these three equations what we get here is, so right from equation 1, 2 and 3 we get what we have here is in equation 1 we have the area of triangle BCYE, parallelogram BCYE is equals to area of parallelogram BCFX. Okay, if we multiply 1 by 2 on the both side, okay, on multiplying one by 2 on both side in above equation, what we get is we'll get 1 by 2 of BCYE, this is area, equals to 1 by 2 area of BCFX. Okay, and equation 2 and 3 are giving us that this is equals to area of triangle ABE, and this is equals to area of triangle ACF, and that's what we were asked to prove in the question. Okay, so what we got is first we have proved that the area of two parallelogram is equal, then we have proved that the area of the one parallelogram is equals to the half the area of this parallelogram is equal to area of AB, and similarly half the area of this parallelogram is equals to area of triangle ACF. Okay, from this we got the required result. Okay, so that's the answer number 8. Let's move to the question number 9. Here we have the side AB of a parallelogram ABCD is produced to a point P. A line through A and parallel to CP meets CP. So what we have first here is we have this parallelogram ABC. In this parallelogram, the AB is produced till point P. This side AB is produced till point P. Okay. Then a line through A parallel to CP. So we have a line through A which is parallel to this CP meets this extended CB at Q. Okay. This AQ is meeting the extended CB at Q. Okay. Then parallelogram PBQR is complete. So what we got is this parallelogram PBQR. So it's given that this is a parallelogram. Okay. Show that the area of parallelogram ABCD, which is this one, is equals to the area of parallelogram this PBQR. Okay. We are given a hint here that we have to join the AC and PQ. Okay. The answer number 9. First we'll write the given part. Given here is a parallelogram ABCD in which side AB is produced to point P. Okay, so we have produced first AB till point P, which is here, and a line parallel to, so what we have that CP is parallel to CB. CP is parallel to AQ. Okay, so I'll write a line through A parallel to CP meets CB at Q. That is, what that means, this AQ and CP are parallel. That is, AQ is parallel to CP. Okay, such that we have this PBQR parallelogram, such that PBQR is a parallelogram. Okay, so this is given to us. We have a parallelogram ABC in which side AB is produced till point P. There is a line through A which meets CP. We have a line through A parallel to CP meets CB at Q. Okay, such that AQ is parallel to CP, and we have this parallelogram PBQR. Okay, what we have to prove here is we have to prove that the area of parallelogram ABCD is equals to area of parallelogram PBQR. Area of ABCD is equals to area of parallelogram PBQR. Okay, so we are going to start with the construction. Construction here is we are going to join this AC and PQ. So after joining these two, we got a figure like this. Now we're going to operate this in this figure. Construction is join AC and PQ. Okay, now let's start its proof. So we are going to start with the parallelogram ABCD. Okay, so we'll write, since AC and PQ are diagonals of parallelograms, so we have parallelogram ABCD and PBQR respectively. Therefore, okay, since this AC is a diagonal of parallelogram ABCD and PQ is parallelogram of parallelogram PQ is a diagonal of parallelogram PBQR, and we know that a diagonal of parallelogram divides into two triangles of equal area. Okay, so what we get is the area of triangle ABC will be equals to half the area of parallelogram ABCD. Okay, area of half the area of triangle ABC will be equals to half the area of parallelogram ABCD. Okay, and area of triangle PBQ will be equals to half the area of parallelogram RQ. Okay, so that's our equation number 2. Now we are going to look at the triangle ACQ and APQ. Okay, now in triangle ACQ and triangle AQP, these two triangles are on the same base. Their same base here is this AQ, and we are given there this AQ is parallel to CP. That means they are on the same base and between the same parallel. That means the area of these two triangles will be equal. Okay, so right now let's change it to the triangles ACQ and AQP are on the same base. Same base here is AQ, and between the same parallel lines are AQ parallel to CP. Okay, therefore area of these two triangles will be equal. That is, area of triangle ACQ will be equals to area of triangle AQP. Okay, so let's name it equation number 3. So what we are going to do here is, now we are going to subtract the area of this triangle, this common region. Okay, this area of this region we are going to subtract from the both the triangle, okay, which is ABQ. Now on subtracting the area of triangle ABQ from both sides in equation 3, we get what we get is, that is area of triangle ACQ minus area of triangle ABQ. Okay, on the other side we have area of triangle AQP minus area of triangle ABQ, and when you subtract the two you will get the result as this one will be area of triangle ABC will be equals to area of triangle BPQ. Okay, let's name it equation number 4. Now we are going to insert the value of area of triangle ABC from here and area of triangle BPQ from equation 2. Okay, now we'll write on using equation 2 and 1 and 2 in equation 4, on using equation 1 and equation 2 in equation 4, we get what we get is, at the place of this area of triangle ABC we can write this half the area of triangle parallelogram ABCD. Okay, so at the place of this we can write half the area of parallelogram ABCD from equation 1 equals to, for this triangle we can write half the area of triangle PBRQ. Okay, or you can say QR, PBQR. So after cancelling this 1/2 from both sides, we'll get area of parallelogram ABCD is equals to area of parallelogram PBQR, and this is what we were asked to prove here. Okay, so what we did here is, First, by applying the theorem, we got that the area of the both triangle is equals to the half the area of the respective parallelogram, because they are formed by the diagonals, okay, of the parallelogram. Okay, then we have proved that the area of those two triangles are equal. Then by using those above equation 1 and 2, we get the required result. Okay, so that's the answer of question number 9. And let's move to the question number 10, which is diagonal AC and BD of a trapezium ABCD with AB parallel to DC intersect each other at O. Prove that area of triangle AOD is equals to area of triangle BOD. Okay, so let's draw its figure first. So this is our parallelogram which is named as ABCD. Okay, and AC and BD are two diagonal, as you can see in the figure, and AD is parallel to AB is parallel to DC. These two sides are parallel, intersecting each other at O. Okay, we have to prove that the area of AOD is equals to area of BOC. AOD is this one and BOC is this one. We have to prove that the area of these two triangles is equal. Okay, this is very easy. Let's first write the given part. This is answer number 10. Okay, given here is a parallelogram, sorry, a trapezium ABCD. Given is a trapezium ABCD in which diagonals AC and BD are intersecting at O. Okay, and AB is parallel to DC. So this is given to us. What we have to prove here is that the area of triangle AOD is equals to area of triangle BOC. Okay, let's start this proof. Now, as we know that in a trapezium the one pair of opposite side is parallel. In this AB is parallel to DC. Okay, so we got one pair of parallel lines. Okay, now for this triangle ADB and triangle ACB, they are the triangle who are on the same base AB and between the same parallel AB and DC. So that means the area of these two triangles has to be equal. Okay, so we'll write, since the triangles, we have two triangles which is triangle ABD and triangle ABC are on the same base. Same base here is AB, and between the same parallel, which is already given that AB is parallel to DC. Therefore the area of these two triangles will be equal. Okay, that is therefore area of triangle ABD will be equals to area of triangle ABC. Okay, so now what we are going to do is, first let's name it equation number 1, and this is by the theorem 9.2. Okay, which says if two triangles are on the same base and between the same parallel, then the area of the two triangles will be equal. Okay, so what we are going to do is, we are going to subtract the area of triangle AOB from both sides in equation number 1. Okay, on subtracting area of triangle AOB from both sides in equation 1, we get, okay, we have the area of triangle ABD minus area of triangle AOB equals to area of triangle ABC minus area of triangle AOB. Okay, so when you subtract AOB from ABD, you will get the area of triangle AOD. Okay, and on this side you will get the area of triangle BOC. Okay, and that's what we were asked to prove here, that prove that the area of triangle AOD is equals to BOC. Okay, so that's the answer of question number 10 of this exercise 9.3. okay, so with this we have concluded this session. Remaining question will be covered in the next session, that is will be the last session for this chapter and the exercise. Okay, so that's all for now. Thanks for joining here. Thank you.